All right, let's see if you know the terminology. An index, indices for multiple, so the small number above the top right of a large normal sized number. Do you know what the other names for them are? One starts with a P. Power. And E? Exponent. Well, good job. Some Americans call it order as well. That's why they call it BODMAS. We call it BEDMAS, E for exponent. Who cares? It's the same thing. These are numbers written in superscript, which is small, above and to the right of a particular base number written at normal size. So if I look at this, base number 2, index 3, what does this tell you? It tells you the base number of, what is the base number of that situation? 2 is multiplied by itself how many times? 3. So that means 2 times 2 times 2, which is 8. We can do operations between numbers with powers 2. You can see this situation. 6 to the 5 times by 6 to the 12 is ridiculous. I don't want you to waste time writing all of that and accidentally miss a 6 and then stuff it up anyway, okay? Do you agree that that's incredibly inefficient to write all that? Instead, we have index laws. So this is where your notes should start. I hope that a lot of this is revision, but I know the bottom won't be, which is on reciprocals. So we have a bunch of index laws that apply to situations involving indices. If A and B are base numbers, do you remember seeing this law last year? If you've got the same base number and you're multiplying them, what do I do with the powers? I add them together. So in this situation, what is the base number that I've underlined here? X. And I'm multiplying them. So what do I do with those powers? X is equal to 6 plus 3, which is 9. That is your shortcut, okay? So a couple of moments to get that first one down. We'll work our way down. Number 2, what is a fraction bar? What operation in maths are we doing with a fraction bar? Dividing, good. So same base number divided by same base number. What do I do with the powers? I subtract them. So if I have this purple example here, are they the same base number? The base number is 3. They're dividing. So your answer is going to be that same base number, but the first power take away the second. Do I know what x is? No. So I just leave it. It's going to be 3 to the power of x minus 2. If I knew the top was 3 to the power of 5, then it'll be 3 to the power of 5 take 2, and I can work it out. But because it's x, I'll leave it at 3 to the x take 2. Get that example down, please. All right, example 3. If I have a base number raised to a power, within brackets, raised to another power, what do I do with the powers? I times them together. Now you're looking at this example and telling me, Mr. T, are you having a stroke? That's not a base number raised to a power, raised to another power. Yeah, it is. You're just not seeing it. Is there a number that I can square to get 9? Good. So if I replace 9 with 3 squared, and then I put it in brackets because I've replaced the 9 with 3 squared, and it's raised to the power of 4, what does that rule tell me to do with the 2 and the 4? Multiply them together. Because in algebra, we don't write the times symbol. So if you have 2 letters next to each other, you just assume it's multiply. So it's 3 to the 2 times 4, which is 3 to the 8. Can you get that example down, please? They get a slightly more complex now. Number 4. What operation is happening between the A and the B in the brackets? We don't write it. They're multiplying. So if I have 2 base numbers multiplying within a set of brackets raised to a power, that power spreads like COVID. It spreads to both. So here, what is the operation happening between 2 and x? Timesing. So that 3 needs to spread to both. So an in-between step, you should write 2 to the 3 and x to the 3. So you can see that it's spread out. You wouldn't get full marks for this. Even though that's right, there is nothing stopping you working out what 2 to the 3 is. What is 2 times 2 times 2? 8. So to get your full marks, you need to simplify or actually work out the thing you can work out. You can't work out x to the 3 because you don't know what x is. But you can work out what 2 to the 3 is, yeah? Okay, that one. 3 more, and then we'll do one example, and then I'll shut my mouth. Number 5, what are you doing with A and B? You are dividing. But the power spreads like COVID again, because can you see the M spread to the A, the M spread to the B. So let's see. This isn't just a simple application of that, okay? Because what is on the top in that example? 3c. So I'm going to raise 3c to the power of 4. What am I going to do to the B? Raise it to the power of 4. What do I do with that top? Because it's a set of brackets. Do we have a rule that shows you what happens when I multiply 2 things and there's a power? That has to spread again. So that's going to be 3 to the 4 times by c to the 4 over b to the 4. Is there anything stopping me working out what 3 to the 4 is? No, you should work it out. 3 times 3, 9 times 3, 27 times 3, 81. C to the 4 over B to the 4. You'll get most of your marks for this because you've shown me you can do the rules, but to get full marks you need to simplify. 2 more examples and then, 2 more like showing you how it works, and then we'll do one complex example together. Number 6, anything question? Oh, you're just playing with you. Anything raised to the power of 0 is 1. Please don't forget that. That will be very useful if you do future maths. Anything that is raised to the power of 0, as long as the base number itself is not 0, is 1. So 4 to the 0 would be 1. 256,301 to the power of 0 is going to be 1. Please don't lose a mark to that one. I would like to think that my colleagues that have had you before covered what they're supposed to. 1 to 6. Okay, you may have done it but forgotten it. That's my way of showing. Okay? What should be new, because I've experienced it before, not just your class, like all Ignites, is you're not familiar with Rule 7, which is to do with reciprocals. Okay? What is a reciprocal? It's when it's a fraction and it's flipped over. So if I had the fraction 1 over 2, what would the reciprocal of that be? 2 over 1. Yeah. So this last rule deals with reciprocals. If I have a fraction, a over b, and it's raised to a negative power. As soon as you see a negative power, we're talking reciprocals here. In the second step, what did removing the negative power do? It used to be a over b when it was a negative power. Now I dealt with a negative power. What happened to the b and the a? They flipped. So the negative power inverts the fraction. And then you've seen a rule like this before. If I'm dividing them, what happens to the power? It spreads like COVID to the top and the bottom. So then you have this situation. So here I've got an example, 3 to the power of negative 2. Can I write 3 as a fraction? What would 3, the whole number, be, but written as a fraction? What?
1/3. 1 over 3.
You're skipping. What is 3? What is the whole number 3, though written as a fraction? 3 over.
3 over 1.
Good. Right? I'm raising that to the power of -2. I'm going to deal with a negative power. So what is the negative power going to do to that fraction? Flip it. So now it's going to be 1 over 3 raised to the 2. And that 2 is going to spread like COVID. 1 squared over 3 squared. What is 1 squared? It's 1. What's 3 squared? 9. Example. That should also explain to you why we used sine, cosine, and tangent to the -1. Because multiplying by the reciprocal of something is the same as dividing by it, right? And we couldn't use divide by tan because the calculator freaked out, right? So what do? We multiplied by sine to the -1, which is the reciprocal of sine, okay? This last one here, 2 over 3 to the power of -2. What is that fraction going to be when I deal with a negative? 3 over 2, and it's going to be squared. And then the squared is going to spread like COVID. 3 squared, 2 squared. 3 squared is 9. 2 squared is 4. And you get those examples down, please, or demonstrations of those rules, the index laws. And we'll do one sort of example that combines everything. And then I'd ask you to practice some of them, but it's pretty chill. This topic should be pretty chill. It'll help you up your average. But then, next topic, you've got your first assignment. I know you don't like writing, but I want to be the one that makes you do an assignment in maths so you're ready for next year and the year after, okay? Have a look at that complex example there. Is there a power applying to the 20? It's not in brackets, there's no power there. Is there a rule that we can apply to the x to the 3 to the 6? What do I do with those powers? Multiply them. So it's going to be 20. X 3 times by 6 is 18. Over 5. What do I do with the powers? The 2 and the 7. Times them again. X 14. Is there anything stopping me working out what 20 divided by 5 is? That's just a number. It's going to be 4. Do we have a rule that tells you when I have the same base number and they're being divided, what do I do with the powers? Minus them. So it's going to be x to the power of, what's 18 take 14? 4. Fully simplified. Okay? So your exercises today, they will build from a one-step thing, like the examples, up to more stuff like that. There's a lot of them. Because I don't shy away from practice. I am where I am because I do. It's the hard way, but it's up to you to decide how much of that practice you do.